Hello, this is Pravina. I'd like to talk about Osi Reference Model. So the overview of this topic is, what is the need for standards? What is that standard which has been adopted? The Osi Reference Model, Layered Network Model, the 7 Osi Reference Model layers, and the summary of all these things. So first of all, we'll like to know what is the need for standards. Over the past couple of decades, many of the networks that were built use different hardware and software implementations. As a result, they were incompatible. It became difficult for networks using different specifications to communicate with each other. In order to address this problem of networks being incompatible and which was unable to communicate with each other, the International Organization for Standardization researched various network schemes. Then they concluded and came to a conclusion that they will recognize and create a network model that would help the vendors to create interoperable network implementations. So that is how the OSI introduced a standard, and which was also called as the OSI model. That is, the ISO, Organization for Standardization, they introduced an international standard which was called as Open Systems Interconnection Standard. And this was called as Osi Reference Model. So in 1984, in order to aid the network interconnection without necessarily requiring a complete redesign, the OSI Reference Model was approved as the international standard for communications architecture. So what is this OSI Reference Model? The model was developed by the International Organization for Standardization in 1984. It is now considered the primary architectural model for intercomputer communications. So OSI Reference Model is a descriptive network scheme. It ensures greater compatibility and interoperability between various types of network topologies. The OSI model describes how information or data makes its way from application programs such as spreadsheets, Word, etc. through a network medium such as wire to another application program located on another network. The OSI reference model also divides the problem of moving information between computers over a network medium into 7 smaller and more manageable problems. This separation into smaller, more manageable functions is known as layering. So what is a layered network model? The OSI reference model is composed of 7 layers. Each will specify their own network functions. So the process of breaking up the functions or tasks of networking into layers reduces the complexity. So each layer will provide the service to the layer above it in the protocol specification. Each layer communicates with the same layer's software or hardware on other computers. So in the 7 layers, the lower 4 layers, that is the transport, network, data link, and physical, are concerned with the flow of data from end to end through the network. Whereas the other 3 layers, that the upper 4 layers, that is your application layers, presentation layers, and the session layers, are oriented towards services to the applications. So data is encapsulated with the necessary protocol information as it moves down the layers before the network transit. So when we talk about this OSI model, you can just see the 7 layers. That is the application layer, the presentation layer, the session layer, transport layer, network layer, then the data link layer, and the last one is the physical layer. So how do you describe each layer? So application layer is user level, that is at the user level, and it does user level processing. Presentation layer, it represents the data, the syntax of the data, etc. etc. In the session layer, we can see there are certain things which is called as synchronization on the dialogues. When we talk about the transport layer, it is reliable end-to-end transmission. Network layer, unreliable through multi-node network. Data link layer is reliable across physical line, and physical layer is unreliable via telco line. So there are certain examples given here. So application, we talk about telnet, presentation, ISO presentation, ISO session, transport TCP, network IP, HDLC and data link layer, and the cables, that is RS-232, etc. at the physical layer. So let us talk about the layer by layer applications. So when we talk about the physical layer, what is the responsibility of the physical layer? Physical layer is responsible for movement of individual bits from one hop to the next hop. So for example, you can see there is a transmission medium which can be a pipe or a V4, which is half duplex or full duplex. So here you can see it just passes the bits one by one to the other layer. So when you talk about the data link layer, the data link layer is responsible for moving the frames from one hop, that is one computer node, to the other computer node. So the example is just given here. It has a header and a trailer, and it also consists of a data. So this from the network layer comes to the data link layer, passes to the physical layer, and it goes to the next host. When we talk about this particular data link layer, we call it as hop-to-hop delivery. So you have one end system here and multiple end systems here. So how is the data getting transferred from one hop to the other hop? So the hops can be either the system, or it can be the routers, or it can be any other devices. So next, coming to the network layer is responsible for delivery of individual packets from the source to the destination. It is host to host. It is from one particular host to the other particular host. So again you have an header followed by the data. So each packet will consist of a data and a header. So it is source to destination delivery. So one end system, that is end system A, to either end system D or F. So the data passes from one host to the other host, that is A to F. Talking about the transport layer is responsible for the delivery of a message from one process to another process. Network layer, we spoke about host to host delivery, whereas transport layer we speak about process to process. So what is process to process? So in each and every individual computer or a node can have multiple processes. So if there is a transmission happening between one process to other process, so we call it as process to process delivery, which happens in your transport layer. Coming to the session layer, the session layer is just responsible for dialog control and synchronization. Synchronization is nothing but syncing the data. Whatever you get it from the top layer, you sync the data and pass it to the next layer. So presentation layer's job is to translate, to do some compression and encryption using compression technique, encryption, decryption techniques, etc. and attach the data with a header and pass it to the next layer. So next layer is nothing but the application layer, which is responsible for providing the services to the user. So user on the one end uses the application and the services and then moves to the other end on the other host. So this is just the overview of all the layers. So the summary of the layers is just given in this particular slide. Thank you.